All right, I'm going to call this video 1.5 because we're done with 1 but not quite ready for 2. We're going to talk about circumference of circles in video 1.5. And circumference is just a fancy way of saying the perimeter of a circle. So first we're going to start off with the definition of pi. And pi, by definition, is the ratio, the fraction, of a circle's circumference, the distance around the circle, to its diameter. So I've got this real fancy GIF here, or GIF or GIF, I don't know, who cares. And so let's see how well this is really going to work here on the video. Probably not going to work out too great here, but you can see this wheel is unrolling. And initially, notice at the beginning that there is that red rope around it. And as the wheel rolls away, that rope that's going around it is unraveling down here. And so that is the circumference of the circle. Now, the numbers that you see, the 0, the 1, the 2, the 3, that represents a diameter width. So that circle, when it starts moving, it'll go and wedge itself exactly in between that 0 and that 1. So can I write on this? Let's see. No. So anyway, it'll be right. That circle would fit exactly right here to show us that this is 1 full diameter. So what's cool is when you have a circle and you want to know, well, how many diameters would it take to wrap around the whole circle? It takes approximately 3.14 diameters to make up the whole circumference. So that's where we're going to get our formula for a, okay, we're done with you, video. What are you doing? Video, stop. Are you done? Are you done? I don't know what it's doing. It's just going to keep going. So we're going to take this definition of pi, that pi is equal to the circumference divided by the diameter. And we're going to come up with, there we go, we're going to come up with a formula for the circumference. So we're just going to rewrite this. So if I want to solve for the circumference, that means I need to get rid of this divided by the diameter. So how do I get rid of a diameter being divided by the circumference? Well, let's multiply both sides by the diameter. So it cancels out down here. And so the circumference is equal to pi times the diameter. Again, it takes approximately 3.14 diameters of a circle to really represent the whole perimeter of the circle. And that's kind of this cool feature that pi is this constant value, that it's always approximately 3.14 diameters to go fully around a circle. Now, I've got or C equals because we could reference the circumference instead of diameters in radiuses. And so how many radiuses does it take to get a diameter? Well, we could have 2 radiuses to get a diameter. And then what we could do is we could call this 2 times pi times the radius. Maybe if it'll pop up. There we go. So the 2r is nothing more than the diameter. So this is just me rewriting the equation. You could write it pi times 2 times r, or we could just put the 2 out in front and call it 2 pi r. Now, I would say most of the time, if I had to pick one of these two formulas, what I would use personally is just pi times diameter. And then if I have to deal with the radius, I'll deal with the radius. So now we're going to look at a problem in 2 different ways. And you might initially think like the other way that we're going to look at this is a really weird way, but it really makes the problem so much easier. So it says calculate the circumference of the circle. First, round your answer to the nearest hundredth. Okay, so if I want to find the circumference is pi times diameter. And if I look at this circle, the diameter is not 8, but the radius is 8, right? So if the radius is 8, the diameter is 16. So the circumference will be equal to pi times 16. And so now I need to use my calculator. And I could just do 3.14 times 16 and get an answer. But sometimes your calculators, more times than not, will have a pi button on it. And this janky old calculator doesn't have a pi button on it. But if your calculator has a pi button on it, I would just use the pi button. Because it's 1 button you got to press instead of 4, right? If you have to type in 3.14, you just hit 4 buttons. And so since my janky little calculator here doesn't have a pi button, I'll type in 3.14. So 3.14 times 16 to the nearest hundredth is, well, it's 50.24 inches. So what we're saying is if the diameter is 16, then 3.14 of these 16 diameters means that the distance around the whole circle is around 50.24 inches long. Now, if you used the pi button, then you're just going to round it to whatever it rounds to. Okay? So you might also get 50.24. I don't really know what the pi button's going to do with 16, but it should be something approximately 50.24. And I would take, honestly, either answer. Okay? Just make sure you round it to the nearest hundredth. Now, what's going to seem weird is my second way of doing this problem. And the second way of doing this problem says, then write your answer in terms of pi. And so what I mean by that is this. If we still did this problem, if we did pi times diameter, and you plugged in 16 for the diameter, what in terms of pi means is don't do 3.14 for the pi. Don't press the pi button. We would say the circumference is, and I'm going to write the number part first, and then I kind of treat pi like it's a variable. But it's not a variable, right? It's still 3.14. So I would say the circumference is 16 pi inches long. Now, for really the rest of your mathematical careers, for theoretical purposes, this is going to be the preferred answer, 16 pi inches long. Now, honestly, if you needed to go to, like, say, Lowe's or Home Depot or Menards, and let's say you had a swimming pool, and you needed some fencing to go around the edge of your swimming pool so that your insurance company doesn't cancel your insurance, and the guy at Lowe's or Home Depot or Menards is like, well, how much fencing do you need to go around your swimming pool? And if you tell the guy at Lowe's, Home Depot, or Menards, I need 16 pi inches or 16 pi feet, they're going to look at you like you're crazy. And so what they're really going to want to know is this number. Like if you actually use pi as 3.14, how long really is that? So using 3.14 or the pi button in your calculator gives you an actual physical number that you could use. But if you don't use 3.14 or the pi button in your calculator and just leave it as pi, that's the more like mathematical way to write your answer. So 50.24 inches and 16 pi inches are equivalent answers. So we're going to be practicing more with the pi answer this chapter, okay? And it'll really make the calculations kind of easier in the end. Another reason why we'll do pi answers is on standardized tests like the ACT, the SAT, whatever other standardized tests you might take. A lot of them will have their answers in terms of pi. They don't want the actual applicable number like the 50.24. Okay, so example 2, calculate the radius of a circle with a circumference of 100.48 feet. So in this problem, they give us the circumference. And so I'm going to start off with that basic circumference equals pi times diameter. And so they gave me the circumference. They gave me C, 100.48. And that's equal to pi times the diameter. And you might go, well, why don't you use that other formula, that C equals 2 pi r? Because if they want the radius and this one uses the radius, why wouldn't you just use that? And you can if you want. But I like to just remember one formula instead of having to mess around with two. So whenever I solve for the diameter, then I'll have to divide it by 2 to get the radius in the end. So if I want to solve for the diameter, I'm going to need to divide both sides by pi. And so here's where I will actually use my calculator and figure out what this number really is. But first, I got to grab a calculator. All right, let's see. Okay, calculator on. 100.48 divided by, ooh, and this has got a pi button on it right there. Perfect. And I get that the diameter, if I round to the nearest hundredth, is 31.98. And so again, the question, though, wanted to know what's the radius. So here's about the only place I can really try to trip you up, is if I ask for one thing and you give me the other answer. So if I divide that by 2, then the radius comes out to be 31.98 divided by, forgot my 9. 98 divided by 2 gives me 15.99. Now, that was me using the pi button, but if I did 100.48 divided by 3.14, then 100.48 divided by 3.14, that gives me that the diameter is exactly 32, which would then make the radius exactly 16. So just so you know, both of these are equivalent answers. It really just depends if you want to use the more approximate 3.14, or if you want to use the pi button in your calculator, which gives you way more digits than just 3.14. But either one is perfectly acceptable. So now I want you to try example 3, and you can pause the video, try it, or wait until the end of the video and then go back and try it. But we'll talk about this one in class the next day. But we're not done yet. Now we're going to talk about, what if I only wanted to know the circumference of part of the circle? What if I wanted to know the length of an arc? So in the previous video, we talked about how arcs could be expressed two ways. That arcs could be talked about in terms of their degree measurement, or we could actually talk about how long an arc is. So if I wanted to figure out how long just part of the circle is, I still will need to know how long the whole circumference is. But we don't need the whole circumference, we need part of the circumference. So we'll have to talk about a fractional piece of it. So the formula for arc length, so this is kind of the general idea, that we need a fraction of the circumference. And the circumference part, let me click on it. Come on, come on, come on, come on, don't move. Oh my gosh. Are you guys doing this? Seriously? Oh my gosh. Wow, this thing's being quite the pain. Oh, there we go, finally, clicked. So the circumference is pi times diameter, but the fraction part of this, well, how are we going to know exactly how many degrees out of 360 degrees that we want of the whole circumference? And so let me just kind of go back to this point. And what we're going to do is think about a radius being drawn here and a radius being drawn here. And then we talked about this angle that was in between the two radii. And remember, that was called the central angle. And what was so special about the measure of a central angle and the measure of this arc? Well, if I remember correctly from the first video, those central angle and that measure of that arc were exactly the same. So if we want to know how many degrees this arc is out of 360 degrees, then we can also look at the central angle to figure that out. So the fractional piece, this will let me click, perfect, is going to be x out of 360, where the x represents the central angle, or it could just represent the measure of the arc. Depends on which one that you're given. So again, how many degrees out of 360 do we want of the entire circumference? We don't want all 360 degrees out of 360 degrees if we only want part of the circumference. So make sure you got that formula written down there. X over 360 times pi times diameter. So in this example 4, calculate the length, not how many degrees, but the length of arc AB. Well, here's arc AB. And so if I start off with my formula, arc length is equal to x over 360 times pi times the diameter. So how many degrees out of 360 is arc AB? Well, here's the central angle. It's 150 degrees, which means this arc is also 150 degrees. So we want 150 out of 360 degrees of the entire circumference. So times pi times, well, what's the diameter of the circle? Well, the radius is 6, so the diameter is 12. Now, we're going to write our answer in terms of pi, which means what all do I need to type in my calculator? You're going to type everything but the pi in your calculator. So if you type in 150 divided by 360, or you could use it as the fraction button if you want, 150 3/60ths, times 12, when I type that in my calculator, this times this gives me a nice 5. And then we're going to say that the length is 5 pi feet long. So from A to B on the outside here has a length, I forgot my pi, is 5 pi in length. Now, we could also talk about this. The whole circumference is 12 pi, so could I now ask you, how long is the other arc, this major arc, but I don't have a third point to really give it a proper major arc name, but how many feet is the rest of this? Well, it would have to be 7 pi feet, right? Because 7 pi feet plus 5 pi feet would give me the full circumference 12 pi. So there's example 4. Now, example 5, I want you guys to try this. But I've thrown a little curveball here. I want you to pay close attention that I'm asking for the length of arc EFG, which is this arc back here. And so I gave you a central angle that doesn't really belong to that arc. But you should be able to take that central angle and figure out a way where you could talk about this arc behind it. So I'll leave that one up to you all. And we'll talk about that one and example 3 back here somewhere. There we go. We'll talk about examples 3 and 5 in class to make sure that you've got it all figured out. And that's all for video 1.5.